Okay, our topic for today is sex differences, and in particular, sex differences in the brain and psychological differences between the sexes. So there's, on the face of it, several different kinds of differences between men and women, or certainly possible differences. The first sort of obvious difference are phenotypic differences, for example, genitals or body shape or height or weight. There's all sorts of morphological differences. There's physiological differences, like hormonal differences. And the question we want to examine today is whether there's another type of difference, psychological differences. Are there differences in intelligence or emotional states and tastes and preferences? Popular media and books, for example, would have you think, well, of course there are. So here's Simon Baron-Cohen, a psychologist, The Essential Difference, Men, Women, and the Extreme Male Brain. Here's a popular book by a body language expert and his wife, Why Men Don't Listen and Women Can't Read Maps. They have a whole series of books with similar sounding titles like this. And here's the very famous Men Are From Mars, Women Are From Venus. John Gray has a whole series. He's a marriage counselor, has a whole series of books about learning to get along with the opposite sex. And the basic idea there is, well, they're very different. If you want to understand their behaviors, for example, you need to understand their psychology. Now, it's worth pointing out right at the beginning, it's a bit unclear what mental or psychological actually refers to. So there just are these physical differences. But mental is usually thought, well, it's supposed to be something in between, say, the brain and hormones. Those are just physical differences. And behavioral differences. Like, so here's a difference. Men spend more time watching sports or gambling. Those are interesting in themselves. The natural thought is that that might represent some underlying psychological difference. So what we can examine is what are the brain differences between men and women, because that is a plausible cause of psychological differences. And what are the behavioral differences? Because that's a plausible effect of psychological differences. Now, for behavior, we're not really going to look too much at that. Next week, we're going to look at one of the supposedly biggest differences, and that is sexual behavior. Okay, so what about brain differences? Well, here's the largest study, or very large study from 2018, sex differences in the adult human brain. This is from 5,216 UK Biobank participants. It's a little hard to read the abstract there, so let me zoom in here. So here's some of their conclusions. So first of all, it's worth noting they have a large sample size, but the mean age is 61.7 years, so it's an older sample. Okay, males had higher raw volumes, raw surface area, white matter, fractional anisotropy. Females had higher raw cortical thickness and higher white matter tract complexity. There's considerable distributional overlap, which I'll show you some pictures in a moment. Much of that is just due to total brain volume differences, but the subregional differences were not fully attributable to differences in total volume. Also, there's greater male variance across various structural measures. Okay, so they're just making physical measurements of brains. Here's some of the results. So for example, total brain volume on the left there. So substantial overlap, but males on average have a larger brain. Gray matter volume, white matter volume, etc. Lots of those differences, for example, the size of the hippocampus or the amygdala, lots of those differences go away or certainly become much smaller when you adjust for just overall brain volume, which is, of course, to be expected. And they also go away if you adjust for something like height, and the reason there, or body mass. So in general, bigger bodies have bigger brains. So if you look at other animals, for example, elephants have much bigger brains. So you would expect men to have bigger brains just in the mere fact that they have bigger bodies. But now one thing, why are we even looking at brain size? It's not actually clear what brain size has to do with anything. So for example, Albert Einstein, very famously, after he died, they were, we got to examine his brain. We want to figure out what made him such a genius. His brain has been studied and passed around and sliced up in all sorts of different ways. Is it this? but for example, he had a less than the male average brain size, so smaller than average. So clearly not true that brain size is exactly the same as intelligence, for example. But it is true that if you look at animal species and you adjust for brain size, so sure, whales and elephants, of course, have giant brains, but once you adjust for brain size, then, for example, primates are much larger than the other mammals, humans are larger than other primates. So there does seem to be a kind of rough correlation once you properly factor out body size between brain size and intelligence, at least for species. Okay, what are some other differences? Well, one of the major differences, and going back to the Essential Difference book by Baron Cohen, is supposedly between empathy and systematizing. This is a collection of things, cognitive empathy, social cognition. This is something that women are stereotypically better at, but are they actually better at it? Well, here's a test of empathy in 80,000 people. They do things like the eye test. So here's a person, you can just see their eyes. Are they sarcastic, stern, suspicious, or dispirited? The correct answer is dispirited, and women do slightly better than men on average, but it's significantly different, significant in the statistical sense, that is not due to random chance. Also, if you scan people's brains while they take the test, women and men, again, on average, seem to be doing slightly different things. Different parts of their brain are active. What about systematizing? Well, what do we mean by systematizing? Well, for example, see, part and whole relationships. So in that colored picture there, there's a hidden cube, the cube below. See if you can, how long it takes you to find that cube in the larger picture. It turns out that it, on average, takes females longer than it takes males. Of course, again, there's high variation here. And again, slightly different parts of the brain seem to be operating in different levels of excitement, I should say. Okay, both of these are from the Baron Cohen portion of the Is the Brain Gendered debate, which I put up in your extra readings. Okay, here's another way to measure. So here's a different paper by Baron Cohen's group about the empathy systematizing gap. So if you score, some people score higher on both, some people score lower on both. Take the difference between the scores, and the +1, +2, +3, those are how many standard deviations above or below the mean you are. So for example, relatively higher on systematizing than empathizing, you're going to be in the bottom right, that is the red region. Relatively higher empathizing rather than systematizing, you're going to be in the blue region. And if you plot men versus women, of course, men and women are all over the board. You can see from the slices on the picture on the right there. But one thing Baron Cohen was interested in, and this is why his book said, had a subtitle about the extreme male brain. His hypothesis is that autism is a kind of extreme male brainness. Autistic people, both males and females, tend to score extremely high on the systematizing and low on the empathizing, and so they're far off to the extreme S, which is like an extreme version of the male brain. Here's a different study of his. Different study actually, and here it's 500,000 people. So, for example, of the men, less than 1% were extreme type E. almost 24% were empathizers. 31% are balanced, that is within one standard deviation of both of them. 40% were type S, and extreme type S is 4%. If you look at the females who are non-autistic, that's what control means. Still not very many of the extreme types, but much more extreme type E than men, for example, and less extreme type S. 40% of women are type E empathizers. Both of the autistic groups are more extreme S's, and in general, type S is the most common. So it looks like autism is a kind of extreme male brainness that's how Baron Cohen reads the data. Now, you might wonder, how could they possibly have measured 500,000 people? Well, here's how they measured empathy and systematizing there. They just did surveys. So here's 10 questions, standard empathy quotient. I am good at predicting how someone will feel. You just rate yourself. So you might not think this is the best. They have a long appendix about why they chose these particular questions out of many larger questions. It turns out these are highly correlated with a lot of other measures that people take to be good of empathy. Here's some of the systematizing questions. You know, when I learn about a new category, I like to go into detail to understand the small differences. So regardless of exactly whether you call this empathy or systematizing, the point is that men and women on average do different, and it's a significant difference. They rate differently. Okay, so is there a kind of male brain and a kind of female brain? Well, one way to think about that is to ask what it is that you're trying to do. The basic idea behind, now let's take a step back in the abstract and think about natural classification. We talked about this with respect to race. Scientific classification aims to divide the world into these natural kinds. So clear cases of natural kinds are things like the chemical elements. There is just a difference between hydrogen and helium and beryllium, et cetera. They're different kinds of things, but they don't literally have to be elements or have to be fundamental. For example, acid or metal, liquid, carnivore. You know, there's different types of rocks, igneous and metamorphic. And those are thought to be natural kinds. There's a natural classification system. Traditionally, biological taxa like mammal and primate and human are thought to be natural kinds too, although philosophers of biology, many have objected to that and think that they're not actually kinds at all because they're sort of historically contingent or because they're individuals. I don't want to get into that right now. I'll just point out that they are still, species are standard examples of natural kinds, and there's something like natural kinds, but not everybody agrees. So if they are natural kinds, then we can correctly classify different types of molecules or rocks or animals, right? Different people should come to the same classifications if they, in some sense, do it right. That is, the classification isn't just based on human interests. Of course, you can classify things by, you know, where you found them, or how big they are, or what color they are, or who owns them. But those are thought not to be natural classifications. The natural classifications are based on sort of objectively different properties. And how do we know something is like this? Well, for example, there's law-like regularities governing these kinds. This is how helium responds to temperature, or this is how liquids are compressible or not compressible, et cetera. Now, of course, there can be variation in a kind, but the idea is that it's a type of thing. We can use them for prediction and explanation, inductions. So if you see how these 5 metals respond to heat, then you can predict, not for certain, but it's a reasonable prediction that the next metal will respond a certain kind of way. It's a reasonable prediction if metal is a natural kind. If it's an artificial kind, like things in this room right now, well, if I grab 3 things in this room and test them for, say, electrical conductivity, there's no particular reason to think the next thing in the room will be similar in any regard. But if they formed a natural kind, like metals, then it would be reasonable to make an inference based on the examples. That's called induction. Okay, so are there kinds of humans? Well, the kind of obvious view, the first pass default view, is that male and female are natural kinds. So sure, they're both human, that is, they're of a larger kind, just like they're both mammals, for example, but they're different kinds of humans, just like primates and carnivores are different kinds of mammals. But is that really true? I want to put just a little bit of pressure on that. Is it really true that male and female follow these law-like regularities? I mean, imagine you find out somebody is male. What else do you know about them? You might think, well, not too much. If you find out that a rock is an igneous rock, you've learned something about it. You don't know everything about it, obviously, but you have learned quite a bit about it. What if you find out that a human is male? Well, arguably, you've learned very little. And to make matters in some sense worse, a traditional view not everybody accepts this view, but it's a natural view of natural kinds, is that they have essences. So an essence, a kind of maybe a necessary and sufficient condition, that is something that makes it what it is. And there, it's not just that you happen to come up with a definition, but that it's explanatory. The essence of a thing explains why it has the properties it does. So, for example, why is hydrochloric acid different than acetic acid? Well, it's a different molecular structure. It's the atomic structure of a molecule that explains why it behaves the way it does. That's its essence. So, but for humans, for male and female, first of all, it's not clear what exactly the difference is between male and female. It's not clear what the necessary and sufficient conditions are. At first pass, you might try something like chromosomes or gamete production, so the gonads. So you might say something like, if you have ovaries, you're female. If you have testes, you're male. You might try genitals or secondary sex characteristics. Those things are more plausible as necessary and sufficient conditions. But it seems like they're less explanatory for a lot of the differences. For example, hormones seem much more explanatory of many more obvious differences, like, for example, height and body shape. Certainly psychological differences, things like chromosomes are extremely distally related in the causal chain from things like differences. That gets into some discussion of sex versus gender distinction. We're going to talk about this on the very last day of class, what makes someone male or female, and a man or a woman, if that's different, and how they're related. But I want to set those things aside for a second and now talk about the essentialist view of the brain. So a natural leap, well, if there's two different kinds of people, male and female, then there's what the male brain is like and what the female brain is like. Now, Cordelia Fine, in the video that we watched, talking about her book, Delusions of Gender, mentions three problems for this essentialist view of brains. First of all, there's the problem of overlap. So there's big variability within male and female, and that's fine. There's variability within how metals respond to heat or how gases respond to temperature, for example. But in particular, the problem is that there's huge overlap between male and female. Normally, you would think if here's how male brains work and here's how female brains work, there shouldn't be so much overlap. Second is the problem of contingency. So group differences, like differences between men and women on, say, mental rotation tasks, sometimes disappear or even reverse in various subgroups. So she points out a few examples, like if you look at, say, mathematical abilities, differences between men and women, well, differences are different in different ethnicities. Or if you look at, say, white teenage females in the United States, they might report higher levels or lower levels of self-esteem, higher levels of depression than men. But if you move to Japan or sub-Saharan Africa or look at adults or young children, it might be different. So there's a kind of contingency. Well, what do you mean the male brain? Do you mean the American teenage white male brain? Or do you mean the male brain? Because it's not clear that there is such a thing as male. Third, there's Mosaicism. So many dimensions of difference that can independently vary. And I'll talk about at least the first and the third problems in a moment. So let me remind you how much overlap there really is. So, for example, this is just in different parts of the brain. And if you look at, so a D figure of 1.4 total brain volume, that's pretty big. That's a pretty big difference. On the other hand, that's about the same as the difference in height. So D, this is Cohen's D measure of the difference between the means, and you just divide by the standard deviation. So, but once you factor out body size, then the difference in total brain volume basically goes away because it's basically exactly the same difference. So there's huge overlap. If you take, and even that is overlap. So for example, if you take a random male brain and random female brain, it's probably something like 80% of the time the male brain will be bigger. But that's only 80% of the time, not 100% of the time. And if you look at things with smaller differences, like the size of the hippocampus, again, or Cordelia Fine talks about, say, mental rotation, which is one of the largest differences in cognitive abilities. The d-value is something like 0.5. That means if you take a random man and a random woman, it's about a 2/3 chance that the man will have a better spatial rotation abilities. Well, that's actually pretty small. If you take two things that are exactly the same, it's 50%. So 66% chance is not that big of a difference. Let me remind you again of, these are the numbers from Baron Cohen. This is the person who defends that there's essential differences between male and female, because as he points out, 40% of men are type S and only 25% of women are type S. So first of all, there's overlap there. But also it's not true that all men are of type S. Most men are not of type S. So it's a little bit strange to talk about the male brain. Mosaicism is that there's not just a single dimension, more masculine, more feminine. Here's a bunch of different traits that seem to show statistical significance differences between men and women. For example, men on average are better at mental rotation of objects, or more physically aggressive, more interested in things versus people. They're more prone to dyslexia, schizophrenia, drug and alcohol addiction. They're less prone to Alzheimer's. They're more interested in no strings attached sex. They're better at mathematical word problems, but they're worse at mathematical calculation. I could list a whole bunch of things that are thought to be different between men and women. In fact, that are measurably different, I should say. But it's not typically true that it's the same people who, for example, are just more masculine and they have, all 8 of these traits. There's plenty of clearly masculine people, for example, who are very good at mental rotation and very physically aggressive, but not very interested in sex and terrible at math. That easily happens. There's just lots of variation. And so when you say things like, on average, men are better at mental rotation, or on average, men are more risk-seeking, well, it's not necessarily the same people. So again, it's a little bit weird to talk about the male brain when it's just this kind of made up. Nobody, or hardly anybody, I should say, has all of these masculine traits. Okay, so is it really useful to talk about the male brain? Well, Cordelia Fine's going to say no, it's just problematic. But Baron Cohen says yes. He says, look, I'm a scientist. There are these differences. All I mean by male brain is just the kind of brain that more men have than women on average. These are just averages, just like you might talk about the male body shape. Now, but then he just says, not all men have a male brain. So some men have a female brain. Some women have a male brain. Many people have neither one because they have some sort of balance. Now, there's this worry, I think, that very plausibly this kind of labeling just feeds into the already existing stereotypes and leads to serious misunderstandings about the nature of the evidence. So I suspect if you're in a room with professional psychologists, it's still problematic, I think, but it's probably not that bad to talk about things like male traits or female traits or male brain, because you can just point out, of course, they know that there's huge overlap and that there's contingency and that there's mosaicism. So it's not that problematic. But in the popular culture, there's a long history of people making mistaken inferences about essential differences between men and women. They assume that there must be a difference, then they find out, oh, it turns out that males have a slightly larger than average amygdala. That is, if you take if a random male and a random female, there's about a 60% chance the male will have the larger amygdala and a 40% chance it's female. Clearly, we've discovered the difference between men and women. That's just not a great way to try to understand these differences, or at least that's what I would think. But it is true. You have to acknowledge there just are differences. Anybody who comes along and says there is no difference between men and women, well, they're just wrong. There are differences. What's interesting is whether what's a good question, I should say, is whether they're interesting or explanatory, or, for example, what the amygdala has to do with different mental states or emotional responses. We don't really know. Now, also, there's another worry. Are these differences natural? So now it's clear many behavioral and psychological differences are heavily shaped by culture and upbringing. Think about something like drug and alcohol addiction. So sure, there are differences between men and women. More, many women are addicted to gambling, but it's even more men. And men in general are willing to take higher risks, for example, financial risks. But very plausibly, much of the variation is explained by differences in, say, the way they're raised, or differences in circumstances, differences in life histories. Now, so how would you know if these differences are natural? Is this just part of being a man? Well, that's the first reason that people look at these brain differences, is that the brain differences makes it seem like it's biological rather than cultural. But it is important to note that the brain is quite plastic and it's shaped by our experience. So for example, regions of the brain can grow and shrink with use. So it's very natural. Baron Cohen even says many of these brain differences are very plausibly just the result of living in a gendered world where we just treat men and women differently. They're exposed to different environments. But it is also implausible to think that just every single one of these differences is completely irrelevant of sex. For example, many of these differences show up even in infants. So sort of famous studies about, male babies might spend slightly more time on average looking at a geometric shape rather than a face, and the women, the face relatively more than the shape. But these numbers are very close. There's not that big of a difference. It's much like other brain differences. But the point is they show up in babies that are even only just 24 hours old. And so can't possibly be explained by socialization. Also, it's correlated with things like hormonal levels in the amniotic fluid when they take fluid from amniocentesis. And so there are plausible biologically mechanistic explanations for some of these differences. Okay. Last, I want to talk about whether these differences are significant in the sense of being able to explain some of the behavioral differences between men and women. So here I had you watch this debate between Elizabeth Spelke and Steven Pinker in 2005, both psychologists at Harvard. It was prompted by Larry Summers, then the president of Harvard, commenting on, in a general kind of way, talk about women in science, commenting on the gender imbalance of many different jobs. He was talking about, for example, high-powered CEOs of different companies, but also faculty in particular departments at Harvard. His basic explanation, he said, well, here's three types of things. There's the high-powered job hypothesis, that is, men are just more interested in working more hours, working jobs with more stress. They're not as concerned with flexibility, family time. They're more status seeking, more money seeking. His second explanation is that there's differential aptitude, especially at the very high end. I'll talk about what that means in a moment. And third, of course, he acknowledged there's different socialization and there's patterns of discrimination. But he said that roughly he thought these three were ranked in level of importance. That is, importance for explaining the differences. Here's a datum that Steven Pinker shows. So that's why the slide is so messy. It's his slide. Messy image there. Here's underrepresentation of women among tenure-track faculty in elite universities. I'm not sure exactly how it's elite is measured, but for example, 8%, and this is 2005, 8% of mathematics faculty, 12% of chemistry, 6% of physics faculty. So huge disparities. And women are overrepresented in lots of areas too. So what's the explanation for that? This is just undergraduate majors, which again show variability, not as extreme as at the PhD levels, but for example, something like 85% of the majors in various health professions are female. Education is close to 80%. If you go down to, say, engineering, it's below 20, or computer science. And more than 50% of degrees are given to women. Now, as you can see, some of these have shown a trend over time, increasing the percentage of women. That's just because women have been getting more degrees, but now they're well over half. But the relative difference between fields hasn't really changed that much. There are a few fields, like psychology, for example, has become much more heavily women. It, in fact, was sort of in the middle before. Here's PhDs. This is 2009, the only year that I could find this data easily. Group, for example, psychology, over 70% of psychology PhDs awarded in 2009 in the US were to women. Physics was less than 20%. There's philosophy just under 30 there. Mathematics is just over 30, for example. And you can even take these much more fine-grained. For example, if you split up the education ones, then you get, reading education is, I guess that's over 90% PhDs awarded to women. Special education, early childhood teacher education. These are very highly distributed toward women. On the very low end, engineering. Some, for example, nuclear engineering, less than 10% female. So this is just a datum. These just are differences, but what is the explanation for these differences? That's what the debate was about. Elizabeth Spelke suggests that discrimination, sometimes just outright discrimination, but other times much more subtle discrimination, forces can basically entirely explain these differences. Stephen Pinker, sort of defending Larry Summers, agrees that those things make a difference. Yes, there is just discrimination. And there are lots of social and cultural forces pushing men or women into or away from different fields. But Pinker says that biological differences, and he means they're essential differences, he means natural differences, not as a result of socialization, also play a role, and he thinks probably a very large role. For example, they lead to differences in aptitude and differences in interest. Interests in particular is a huge explanation for why people go into different fields. And he claims interests differ and that it's not entirely due to social forces. Okay, so why do they think this? Well, you need to watch the video and see what you think of their explanations. But I'll just mention key arguments from Spelke include known effects of gender on parental and societal expectations. So from a very, very early age, even less than 24 hours, as soon as the baby is born, knowing that it's a male or a female leads parents to treat the baby differently, leads society to treat the baby differently, to talk differently, to say, oh, wow, how cute your baby is versus how big and strong your baby is. And actually, even among people committed to non-discrimination, your expectations actually affect what you seem to perceive. So even parents looking at exactly the same baby, here's one experiment. Parents of male babies tend to describe the babies as, larger, stronger, more robust. But if you look at, for example, exactly the same APGAR scores as male and females. The experiments that I think are really clear at showing the differences in perception I think it was a 6-month-old baby where you really can't tell the difference. But so you have people who don't know the baby, watch the baby playing with toys. They're playing with a jack-in-the-box. The jack-in-the-box goes off. The baby is startled and jumps back. If in the story that you tell the parents the baby's name is David, they're more likely to describe the baby as angry or frustrated with the toy. If you describe the baby as Jessica, then they're more likely to say that the baby is afraid or scared. So, and that is they're watching literally the same baby, the same video. They just watch a video. And so there are significant differences in what you think you perceive. If the child looks like, if you assume that they're scared, and as Spelke says, a very well-meaning parent will treat their child differently if they think their child is afraid versus if their child is angry. So, and then she looks at, this isn't really a perception kind of case, but there's famous studies, for example, creating a CV or a job application, and you blind it. They've done this with race and they do this with gender. So if the person, if this is let's take Jessica and David. I can't remember what the names are, but this is Jessica's CV with the same number of publications, exactly the same everything. And they wonder, I wonder if their advisor helped them write this paper. I wonder if they can really do this work on their own. I wonder if they're going to be good, et cetera. They look at the male name and they think the CV is really strong. We should definitely hire this person. And so that's a case of, it's a kind of discrimination. The same thing happens with race, by the way. If somebody applies for a job and their resume is Letitia or Jerome, I believe, I think there was a more black sounding male name, but I can't remember what it was. Deshaun, maybe. They were much less likely to be hired or given another chance or given an interview, it's next level interview, than the identical resume with more white sounding names. I can't remember what the white sounding names were, but they were white. Okay, so we know that those things matter, but can they explain everything? Key arguments from Pinker. So Pinker acknowledges that those things matter, although he does try to downplay how, first of all, how different parents actually treat their kids, and secondly, how much that actually matters. In his book, The Blank Slate, he has a long chapter on parenting where he says basically parenting matters a lot less than you think. But he acknowledges those things play a difference, but he wants to point out that there's lots of biological differences. For example, he points to the different known differences between male and female brains, says many of these are probably natural. For example, they're different in babies and they're different in other animals. And small differences in the mean, and this is a kind of a statistical point, can still lead to very large differences at the tail. This is at the very high end. This is what Summers was referring to. This is especially true with male variance. So if you take something with higher male variance, so if you take something like, say, height, men are taller than women on average. It's about, as I said, I think there's an 80% chance that a random man will be taller than a random woman. At the mean, I think maybe there's something like 5 inches difference. So if you take a height like, say, 5'8", there's many more men than women at that height. I can't remember what the numbers are. Pinker gives the numbers. But if you go up taller, for example, at 6 feet, the ratio is much more extreme. And at something like 6'4" or 6'5", I'm sure it's thousands to 1 is the ratio. Similarly, if you take something that's a small difference like mental rotation ability or systematizing or empathizing, if you remember going all the way back to the Baron-Cohen data, sure, if you just look at the average, there's more men above the average than women. That's what it means that men are higher on average. Well, it's not exactly the same, but it is true. There's more men that are higher than the average. But if you look at the extreme systematizers or the extreme empathizers, it's true the absolute numbers are a lot lower. There's not that many men that were extreme systematizers, maybe something like 4%. But it was something like 1% female sympathizers, extreme systematizers. That is, so the ratio is something like 4 to 1, whereas the ratio was barely bigger than 1 to 1 at just the regular. 40% of men were systematizers and only something like 20-some% of women. So the differences get exacerbated at the high ends. And there's also much higher male variance. So for example, if you look at something like brain size or regions within the brain, a lot of these abilities, there's a lot relatively more men at the tails, both the high and the low end. So this is what Pinker refers to as the more geniuses, more idiots hypothesis, which seems to be confirmed in all sorts of different traits, not just IQ, that geniuses and idiots come from IQ distributions. But this is true of all sorts of, measures of cognitive differences. Men tend, relatively more than women, tend to be found at the extremes. So that's going to exacerbate these differences. So if you look for someone who's in the top 1% of mathematical abilities, it might be slightly more men than women. But if you look at the top 1/10 of 1%, suddenly now it becomes more extreme toward the males. So how much does that really explain? Well, Pinker's going to say this explains Harvard perfectly. Spelke has reasons to doubt that the connection between these very specific tasks really connects to something like hiring mathematics. She points out things like the best indication of whether someone will be good at mathematics will be something like grades in mathematics classes in college, at which women are at least equal. Depending on how you measure, Pinker says they do better in most classes. But certainly they don't do worse at any level. They don't do worse in graduate school. They don't do worse in undergraduate school. They don't do worse in high school. So it's really unclear where how these very small differences, say in mental rotation tasks, could lead. But as Pinker points out, he's like, well, why wouldn't you think that would make a difference? If you're better at mental rotation of these spatial things, of course that's going to help for certain areas of mathematics. So where does this leave us? Well, I purposely want to leave it unclear. I want you to watch the debate. I want you to think about what arguments you think are powerful and why, whether you think they're directly head on against each other or whether there's some way in which they can both be saying important things or both could be wrong. So I think some things are clear that everyone just needs to know. That is, multiple studies and meta-studies seem to indicate that there are physical differences in, for example, brain structure. There are, on average, between men and women, there are differences in, for example, survey results that you can label empathy and systematizing. There are differences in, for example, survey results of interests of why they go into various jobs. The second thing to know is that these differences are not that different in some measure of statistical effect size, for example, the D measure. There's huge overlap. There's high variance within groups. And so that might make you wonder, so you shouldn't say there just are no differences because that's just wrong. But whether these differences are important in what they explain and why more men go into physics than women, or whether you can seriously write a book called why women can't read maps. I can't remember what men can't do, but men can't take instruction, I think. Or whether it's even worthwhile to talk about the male brain or the female brain. Certainly it's not men are from Mars, women are from Venus. They're both from Earth. So you got to keep that in mind, even if you think that these differences are important and explanatory.